Okay. But screen is visible to you?
Yes, sir.
Today I'm facing some video problems. That's okay. I managed my class with sharing screen. So in last class, we completed our discussion up to session layer. So how many layers in OSM model? 7 layers.
7 layers.
So we discussed about application layer, we discussed about presentation layer, we discussed about session layer, and we complete some part of transport layer. So what is the purpose of transport layer? For example, if you want to send a message from sender to receiver, right? So here we have a network. I mean to say that. So device 1 and device 2 and device 3 and device 4. These 4 devices are connected. They are present in the same network, and it contains one more network, right? So here I want to establish a connection between D1 and D5. I want to transmit data from D1 to D5. So here device 1 and device 5. So device 1 may be a computer, maybe a laptop. Device 5 may be a mobile phone. So device 1 having multiple tasks, task 1, task 2, task 3, task 4. To complete each and every task, your operating system assigns a processor P1, P2, P3 and P4. In the same way, for receiving the data, again, device 5 is also contains multiple tasks, task 1, task 2, task 3 and task 4. And to address all these, to complete all these tasks, your mobile phone also creating process 1, process 2, process 3, process 4. So the best example is, I want to show you something. Are you able to see my screen, right?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
See here, processes, performance. So if you click on processes, all these are applications. Status, performance, app history, startup, users. So here, myself, username. It contains many things are there, memory, disk. So for each and so application frame host, it is one application, calculator, it is one application, client server, it is one applications. When you click on processes, so all these are act as a processes, individual processes, power usage. So you understand that for each and every application, we have an individual status is there, individual CPU utilization is there, and memory is there, disk space is there, network is there, GPU is there, many combinations are there. See, our Zoom meeting ID 32-bit, we are running on it. It occupies almost 9% of CPU and 277 MB of memory, and disk space is 0, and network it is connected to, because some devices are need internet connection, some devices doesn't need any internet connection. So it need internet connection. So it take almost 0.4 Mbps data, and the GPU utilizes 4.6, and the power usage high. Do you understand this? Do you understand this?
Yes, sir.
Yes, sir.
Are you following me or not?
Yes, sir.
That means when we are sending data from one device to another, so I try to map the same concept with in our example also. Here, device 1 and device 5, these two need to interconnect with each other. They try to share some information in this particular context. So for example, task 1 is sending data. Here task 4 is receiving data. Sending data to D5, this particular task is assigned to process 1. Receiving data from D1, so this particular task assigned to P4. So here P1, P4 belongs to same category because P1 sending data, P4 receiving data. P4 receiving data. That means the process 1 of device 1, the process 1, which is your operating system, creates a process and assign to complete task 1 for the device 1. Indirectly meaning is device 1 is a consists of multiple processes. As now just you have seen many processes when I open my task manager. In this context, process 1 responsibility is complete the task 1. That means sending data to D5 and when the data is sent, when the data is transmitted from D1 to D5, in D5 we have a multiple processes. Among those multiple processes, who will take care about the receiving data? P4 in our example. That means process 1, it is also having an address. Process 4, it is also having an address. So that is, if you are process to process delivery, process to process delivery by entire message. So if the message is entire message is transmitted from process 1 belongs to device 1 through this network to process 4 of device 5. This is called service point addressing. Do you understand this? Do you understand this?
Yes, sir.
Any doubts?
No, sir.
Right. So same context, that means to say that, so here device 1 and device 2 and device 3 are present in a LAN, a local area network, and device 4 and device 5, these are present in other LAN, local area network 2, and device 6, device 7, device 8. These are connected to some LAN 3. So to connecting all these things, we need internet. So for connecting this is called network 1. To connect this is called network 2. To connect this is called network 3. So again, device contains multiple processes P1, P2, P3. Again, device 2 also contains multiple processes P1, P2, and P3. In the same way, device 6 also contains multiple processes P1, P2, P3. In the same way, device 4 also contains multiple processes P1, P2, P3. So here, for example, if you want to send any message from D1 to D4, which network I need? Network 1 or network 2 or network 3? If I want to send a message from D1 to D4, which network I need?
Network 1, sir.
Of course, network 1. That means if you want to send D1 to D4, device 1 means it is not only for the purpose of sending data, it is a computer. It is a multitasking. Multitask means it can take care about storing files. It can take care about connecting YouTube. It can take care about open Google. Many things are there. Among those multiple processes, I am having only one process. And device 4 also multiple. I am having one process. So communicating between two processes of two individual devices through network. So here, how many addresses I am using? How many addresses I am using? I'm using process address, I'm using device address, I'm using network address. Yes or no? Yes or no?
Yes, sir.
sir.
Do you understand my point? For example, I take into consider of our class example only. I want to communicate with, for example, I want to communicate with one of the person, uh, for example, KK to some other side, right? So first question is whether Sai belongs to our network or not. Our network means our section or not, first thing. If our section, I don't need any network address, I directly contact to Sai. For example, maybe Kranti belongs to one section, or maybe Sai belongs to some other section. At that time, I need the network addresses, section J and section J. I need these two addresses. So section A of Kranti need to communicate with section J of Sai. So for communication of Kranti and Sai, I need these two addresses, two section addresses. Without knowing these two sections, is it possible to communicate these two fellows? No, right? Hope you understand this point. Here, network address will take care by network layer and device address will take care by data link layer and process address will take care by transport layer. So here we have three things: service point addressing and logical addressing and physical addressing. Physical addressing is nothing but device address. Logical addressing nothing but network address. Service point addressing is nothing but process to process address. So get back to our original content here. You take a look of it. See here. So anybody, could you please tell me what is H4 here? What is H4? What is this header? This header
Address, sir.
contains, this header contains address of source process and address of destination processes. This is P1, P2 and P3. This may be P4, P5, P6. So through internet, network layer will take care about through which network these two processes are communicating, and data link layer take care about whether this process 1, process 2, process 3 belongs to which device. Process 4, process 5, process belongs to which device. That means I need three things here: who actually start a process address, and this process belongs to which device address, and the device is communicated to with other device through which network, that is called network address. Hope you understand this. Or any doubts? You understand this?
Yes,
Okay.
sir.
So service point addressing. Computers have run several programs, right? At the same time, as I said, that this one, sometimes we call it as a program or task, several programs at the same time. For this reason, source to destination delivery means delivery not only from one computer to the next, but also do you hear me?
Yes, sir.
Yes, sir.
Okay. Here I have some bandwidth problems here. So here source to destination, if the capacity of you actually need to transmit 4 Mbps data, but the network capacity is only 1 Mbps. In this particular context, what we need to do, divide this entire message into individual 1 Mbps, 1 Mbps, 1 Mbps, and 1 Mbps. So packet 1, packet 2, I assume that is a packet 1, packet 2, packet 3, and packet 4. So source to destination, here I am showing only one line, but in practical life, source to destination contains many combinations of networks. Router 1, router 2, router 3, and it contains router 4, maybe router 5, router 6, router 7, and connecting, and router 8, router 9, router 10, router 11, and connecting. First, we are sending our first packet, packet 1, from source to router 1. Maybe if the router 1 is busy, then this packet 1 is transmitted to router 4. Router 4 to router 5. For example, packet 1 may be selecting the path source 1, router 4, router 5, router 6, and destination. And packet 2 transmitting the way, packet 2 may be selecting the path source 2, router 1, and router 2, and router 3, and destination. Maybe packet 1 and packet 2, in this context, packet 1 is following the path source 2, router 4, router 5, router 6, router 7, destination. And packet 1 following source 2, router 1, router 2, router 3, destination. Maybe the network bandwidth of packet 1 route is slow as compared to the network bandwidth of packet 2. So that means packet 2 selecting router 1, router 2, router 3. These three routers are very fast. And router 4, router 5, router 6, this path is selected by packet 1, it is slow. So at the destination side, which packet received first? Packet 1 or packet 2? Yeah, please. Packet 2, right? Packet 2. So in the same way, maybe packet 3 path is somewhat slower, packet 4 path is somewhat faster. So in this different context of orders, your order of data releasing like this: P4, P2, P3, and P1. So first he received packet 3, for example, next packet 4, next packet 2, packet 1. But it's supposed to be, it should be reached by P1, P2, P3. What happened, man? Why this was happened today? Just a minute. Do you hear me? My voice is audible to you?
Yes, sir.
Right. So due to this combination, so here the main concept of, so According to our example, your order is maybe packet 4, packet 2, and packet 1 and packet 3. In the receiver side, the order of receiving packets like this, but it's supposed to be the meaningful order is P1, P2, P3, P4. That means I say a message contains, for example, a message start with, hi, how are you? And what is your phone number? And what is your date of birth? For example, if you are not receiving this order, in the receiver side, what is date of birth? How are you? What is phone number? Hi. So is it making sense? This order of meaning, this order of match doesn't have a matching sense. When we
No,
start
sir.
the conversation, we said that, hi, hello, how are you? What is your phone number? What is date of birth? So when we start a conversation, it should be a meaningful way. But at the receiver side, first directly it asking about date of birth. Again, it is asking about how are you? Again, it asking about what is phone number. Again, asking about how. So this is not proper order. We are respecting this order. That is called segmentation and reassembly. Segmentation means your data capability is 4 Mbps. Your message capability, it is dividing into 4 segments. Because your network bandwidth support only 1 Mbps, you're dividing into packet 1, packet 2, packet 3, packet 4. For each packet, it is giving sequence number 1, 2, 3, 4. At the reassembly, when we're receiving P4, P2, P1, P3, what is the sequence number of P4? 4. What is the sequence number of P2? 2. What is the sequence number of P1? 1 and 3. So 4, 2, 1, 3, it is not in order. At the reassembly side, according to sequence number, it is sorted. So first sequence number 1, sorting, 2, sorting, 3, sorting, 4, sorting. So it is the responsibility of segmentation and reassembly. Hope you understand this point. Any doubts?
No, sir.
A message is divided into transmittable segments. Here, transmittable means supportable. How much your link supports, that is called transmittable. With each segment containing a sequence number, this is very important, sequence number. These numbers enable the transport layer to reassemble the message correctly upon arriving at the destination and to identify the replaced packets that were lost in the transmission, right? For example, we are sending actually P1, P2, P3, and P4. Receiver side receiving P4, P3, and P1 only. And the sequence numbers 431, 2 is missing. Again, I request the sender, packet 2 is missing. Please retransmit again. So it can retransmit only 2, not all the things. And next one, connection control. What is connection control? When multiple systems are connected, for example, there should be a dedicated path between device 1 and device 2. Among those two connections, which will transmit, which device take the concept of transmitting actual concept. That means these two devices are connected. Among those D1 and D2, which device start transmitting data, either D1 or D2. For example, it is act as a client, it is act as a server, then server having a more superiority than client, then server sends a signal to D1 to receive the package. Connection control. And among, for example, a single link was shared by, it is a broadcast link. A single link was shared by device 1, device 2, device 3, and device 4, and device 5. So if for example, all 60 members are connected here, if we talk at a time, then there might be a chance of loss of signal. For example, 60 members are talking with each other. We are not able to transmit meaningful information. For example, if I am talking something, you should be silent. And when I raise a question to some other specific student, if he replied to my question, then it should be meaningful information. So in this particular context only, when multiple devices are connected, I need to tell which device start the data, or which device need to start transmission of data at that particular time. For example, here we have 60 students are here. Now in this context, I am talking something to, I am explaining something to my student, and I request one of the student, for example, Srinidhi 6002. Srinidhi, are you there?
Yes, sir.
Yes. That means when I mention, for example, I am asking a question, what is your name? My question is, what is your name? I'm not mentioning any person. So how many responses can I expect here? Almost 60 responses. So whether it is making sense, at a time, all 60 members telling their own name. So entire channel is busy. Entire channel is We do not sharing, entire channel is garbled, and due to overlapping of the voice messages, we are not able to understand what I am talking is, what exact information is sharing is. For example, if I mention roll number 6002, what is your number? What is your name? Srini.
Srinidhi.
Yeah, roll number 6003, what is your name? Mani Venkat Pradeep. That means when I mention, so among all these 60 are connected to Zoom, I specifically mention who control the channel. That is called connection control. Connection control means who need to respond. I need to decide that one. So this type of action will take care by transport layer according to connection control concept. And next one, flow control. Flow control means flow control means, for example, we are starting playing a game. So I have a 10 balls. I can throw one ball for 1 second. I can throw one ball. But receiver capabilities, for example, within, I mean to say that sender having 10 packets of data. So sender can send 10 packets in 1 second, but receiver can receive 5 packets in 1 second only. In this particular context, if sender sends 10 packets at a time to receiver, how many packets can received by the receiver at most? Only 5 packets. And the rest of the 5 packets, they lost. In this particular context, I want to avoid the loss of data. Then sender down his speed, and it can send only 5 packets per second. So flow control means sender and receiver should be in synchronized fashion. Whatever the data actually the receiver can handle, that much of data only I can send. For example, if I start my class and explain all the class in a very standard way, and I'm not giving proper explanation, and I said that syllabus is completed, but I need to understand I have a 60 students. Among the 60 students, I need to consider backbench boys, I need to consider intelligent boys, and everything. Depend upon a requirement, I need to start my class. Depend upon your locality, I need to take the examples. Right? This is called flow control. And next one is error control. Error control means, so here we are, Hamming code and everything, right? Hamming code, parity checking. So error control, if data is lost, for example, error occurred, if I am sending 1001, at the receiver side, I'm receiving 1010. So I'm checking sender and receiver, both are same or not. If the data is not same, again, I'm expecting retransmission of data. Otherwise, I can apply Hamming code here and checking for where the error is occurred. And I can change the error and state to the particular thing. So these are the some of the examples. And here, network layer. So network layer responsibility is hop-to-hop delivery. Hop-to-hop delivery means here, A, B, E. So we have a different types of networks. So the network layer is responsible for social destination delivery of a packet possible across multiple networks, whereas the data link layer oversees delivery of the packet between two systems on the same network. That means main difference is if device 1 and device 2 are existing in the same network, and I can say that the best example. So roll number here, we have roll number 6003 here and roll number 6001 here. So these two are belongs to same section or not? Six double zero one, are you there?
Yes,
Chandra?
sir. Yes, sir.
Yeah, 6003. Mani Venkat Pradeep, are you there?
Yes, sir.
Yeah. So these two people are belongs to same network means I do not need to mention what is section. No need. Yes, sir. There because if they need to communicate with each other, they forget about what is section. For example, if maybe Chandana belongs to section A and maybe Venkat belongs to section C, then lot of Chandanas are present in section A, and maybe Chandana, the same name with Chandana is also present in section C also. But I clearly mentioned that I need to mention Chandana is a name and a particular student. He belongs to section A, section A need to communicate with Venkat of section C. That means Chandra is actual device. He belongs to network section A. Venkat is actual device. He belongs to section C. In this, so when these two devices are connected in different networks, you need to mention network name. Are you following my point or not?
Yes, sir.
Right? So in this context, but so data link layer responsible for data transmission between two devices. If those two devices are existing in the same network, data link layer is sufficient, physical layer is sufficient. But if those two devices are existing in two different networks, individual networks, then you need to identify the device name and where this device is present, that network name, and device to network name. If you know the network, then only you are able to communicate with each other, right? So other responsibilities of network is logical addressing. I already explained. The physical addressing implemented by the data link layer handles the addressing problem locally. Locally means if we are all connected to, for example, we are all connected to Zoom link. This Zoom link is a single network. Here I'm having all the details, 6013 here, 6012 here, and Vincent here, Joshika here, Raidu is here, Nikhil is here. We are all belongs to same network. So we do not need any specific address because we all belongs to same network. I am able to identify those things. But in case of logical addressing, when two persons or two systems present in two different networks, if they need to communicate at that particular context, if you want to address all those things, I need logical addressing concept. Logical addressing is nothing but network addressing, and routing means it can decide according to shortest path or according to minimum number of hops, according to minimum distance. Different parameters are there. That is source and destination here. So here we have a router 1 and router 2 and router 3 is there. Here only router 4 only is there, and here router 5 and router 6 is there. So you can follow many paths. Among these multiple paths, which one is better? Because it contains only one router is here, then I can go with this path. So multiple packets are transmitted this path only. After some time, all packets are using the same path. Due to this, maybe traffic is very high. At that time, I can change my direction to router 5 and router 6. Router 5 and router 6. After some time, if this packet is also busy, I go with third path. It is called routing. I can decide from which network to which device, from which network to which network I can transmit my data. So this is something about network layer and data link layer. So it can take care about logical addressing, logical link control, media access control. Logical link control means same thing. When multiple devices are connected to same network, inside the same network, device 1, device 2, device 3, device 4, they are all connecting. Among those multiple connections, which device having more priority to communicating and which device having less priority to stop communication. So to avoid garbling, to avoid the errors, you need to decide flow control, error control, everything. The responsibilities of data link layer and transport layer both are same, but in case of data link layer, flow control, error control, connection control will take care about in a single network of this single data packet only. But in case of transport layer, connection control, flow control, error control for entire message. Message is dividing into packets. Packet is dividing into frames. Message is transport layer. Packet is network layer. Frames for data link layer. So if this connection control, flow control, error control will take care by data link layer for frames only. But connection control, flow control, and error control will take care by entire message in transport layer. That is the main difference. Hope you understand this. So the main responsibility of data link layer, we call it as a frame here. So in physical layer, the data is in the form of bits. In data link layer, the data is in the form of frames. In network layer, it is in packet. And in transport layer, we can tell TPD, protocol data unit, or sometimes we call it as a message also, entire message. See here. So data link layer, hop to hop delivery, hop to hop delivery, and hop to hop delivery. Data link layer. Right? So other responsibilities are framing, physical addressing, flow control, error control, access control. So framing means dividing the entire data into multiple frames. At the lower level, at the physical layer level, all are in the bit format. We can convert in these bits into multiple packets. Multiple frames. Multiple frames are leads to multiple packets. Multiple packets related to messages. So simple journey is, I'll explain in a simple manner. Message always huge. This message is dividing into multiple packets. Again, these packets are dividing into multiple frames. Again, this frame is converted into stream, bit stream. Because end of the day, either we are using coaxial cables, either we are using fiber optics, all these channels are supporting bit format only. They don't know what is packet, they don't know what is frame, they don't know what is message. So this entire message is dividing into packets, entire packet dividing into frames, entire frame is dividing into bits. That bit is transmitted via a channel, a physical channel. At the receiver side, again bits are converting into frames, frames are converted into packets, packets are converting into actual message. That message will be easily understood by that particular receiver side. So physical addressing, indirectly it is MAC, media access control addressing. We already shown in network commands, we have shown get MAC ID. Get MAC, do you remember that point or not? Get MAC. Yes or no?
Yes, sir.
Yeah. So there, and framing means anyways, in coming classes, I clearly explain about flow control, error control, access control, everything. So access control means when two or more devices are connected to the same link, data link layer protocols are necessary to determine which device has control over the link. That is, on that particular context of time, which device start communication. When one device start communication, other device need to stop. If both devices are sending their packets in a single channel, then definitely there might be a chance of occurring errors. I can say that when multiple people are talking with each other at a time, automatically that we are not able to understand and our area is not capable to understand whom are talking to whom and what they are talking about. And error control means, for example, we belongs to same network. So here device 1 and device 2. So from device 1, creating frame 1, frame 2 and frame 3. These three frames are transmitted to device 2. Then during the transmission, frame 1, frame 2, frame 3 is transmitted. Maybe frame 1 lost. During the transmission, due to damage or something else or connection loss, frame 1 is lost. Then device 2 will take care about frame 2 and frame 3. If frame 1 is lost, then I request in device 1 for retransmission of frame 1. Otherwise, frame 1 data is like this 101001. If any particular due to garbage or due to error or due to third-party user, any data is garbled or changed, then you can apply so many error detection methods are there, error correcting methods are there. That is parity checking, even parity checking, odd parity checking, horizontal redundancy checksum, vertical redundancy checksum, and CRC. Many combinations are there. In coming units, we will explain about it clearly. We'll explain and demonstrate about all these error detection and correction methods. And we already explained what is flow control in transport layer. The same thing applicable to here also, but here it will take about frames. There we will talk about messages. And finally, physical layer, the lowest layer. So it contains when from data link layer, data is in the form of frames. Once it is moved to physical layer, this entire frames are converting into individual bits and followed by the address also. Address is also in bit format. At the receiver side also, at the transmission medium, this transmission medium is nothing but optical fibers or coaxial cables or twisted pair or many combinations there, whether it is connection oriented or connectionless, many things are there. At the receiver side, the same bits are received. When I'm going to data link layer, this entire data is again converted into frames. This frame may be fixed size or variable size. And other responsibilities of physical layer is physical characteristics of interface and medium. That is, characteristics means if you are opting optical fibers, what is the capacity and what is the medium required? If you are opting coaxial cables or Cat4/5 or 5, what is the capacity? Whether it is 250 Mbps or 150 Mbps, depend upon your network size, depend upon your requirement, we can define what medium we need to use, what transmission medium we are using, and the representation of bits. Yes, of course, everything should be in signals. So representation of bits responsibility is converting your bits to signals. At the center side, receiver side, signals to bits. I meant to say, when you mention 1011, 1 means higher bit, 0 means lower bit, 1 means higher bit and higher bit, like this. So these bits are converted into signals. At the receiver side, again the signal is converted into actual bit size. That is called representation of bits. And data rate or transmission rate. Data rate means the number of bits transmitted per second. The number of bits sent each second is also defined by the physical layer. In other words, the physical layer defines the duration of a bit, which is how long it lasts. Number of bits within unit of time. If you are taking coaxial cable, what is the capacity? How many bits it can transmit? If you are go with optical fibers, how many bits it can transmit? Like those things. These are the very basic things. Synchronization of bits. The sender and receiver not only must use the same bit rate, but also must be synchronized at the bit level. In other words, the sender and receiver connectivity. So that means, for example, here I am starting my journey 1011, 1011. So receiver side also, I can take the same order of things. Clock. Clock means it in this particular 2 seconds of time. 2 seconds of time. Here I am supporting 4 bits only. Receiver also in 2 seconds of time, it's supporting these 4 bits only, not more than that, not less than that. Synchronization means the number of bits transmitted and the starting and ending of the same bit stream should be equal to the count and starting and ending of the receiver side also. Both should be same, not different. Line configuration means we already explained whether it is a dedicated link or broadcast link. If it is a point-to-point link, entire capacity is allocated to those 2 devices only. If it is a multi-point link, who will take care about it? Sharing link. Physical topology, many combinations. Here we have a star topology, mesh topology. In coming classes, I'll explain what is topologies. And transmission mode, we already explained how duplex, full duplex, and duplex. So this is something about ISO-OSM model. This is a general view, a general explanation of application layer. Taken about the access network services, presentation layer, translate, encryption, compression, session layer, establish, manage, terminate, transport layer, process to process delivery, network layer, packet from source to destination, provide inter-networking, data link layer, hop to hop delivery or device to device delivery, physical layer, transmitted over the bits over the medium. That medium depend upon your requirement. So the same thing equal to TCP also, but in case of ISO-OSM, we have 7 layers, and TCP/IP we have only 4 layers. Some textbooks supporting 5 layers also. It is your assignment. Your assignment is, I will give some assignment topics, but at least by next week, you need to complete that assignment. Next week, I will give sufficient time for you. See here. So here we complete protocol layers and their services and models, history of computer networking and internet, and your assignments are internet, the network edge. The network edge assignment topics are, please take a note of it, internet, network edge, and TCP/IP model. These 3 topics are your assignments. TCP/IP model, whatever the things I explained in ISO model, almost all are same. But here they are using whatever the 7 layers doing in ISO model. They're divided all those, they're divided this entire task and distributed to 4 layers in TCP/IP model. Explanation is same. It also contains internet network layer. It is also contains transport layer. But your responsibility is write assignment for TCP/IP model, write assignment on internet, write assignment on network edge. Tomorrow we will discuss about what is delay, what is lot, what is throughput in packet switching networks. I will explain all these things, switching networks. Right? So still we have a this is only network core. This is pending. Rest of things we completed already. History of computer networking and internet. So you people take care about internet and the network edge, and followed by TCP/IP model. Are you getting my point?
Yes,
Are you
sir.
getting my point? Yes, please. Please respond.
Yes, sir.
So I request all the students, read the contents properly, go for the standard textbook and read what is internet, write assignment on paper, and I will create the assignments on Moodle box. When you got an access for that one, upload all the assignment topics in that Moodle box itself. Assignment topics are, topic 1 is internet, topic 2 is network edge, and topic 3 is TCP/IP model. Write assignment on these 3 things. So I am not going to explain anything about this one because they are very basic concepts. TCP/IP model is almost as same as ISO OSI model. So by next week, complete this task and upload in Moodle box. Tomorrow we will discuss about what is packet switching and what is different types of delay, loss and throughput on those things. If it is completed, our network, our module 1 will complete automatically. Thank you.
Thank you, sir.
Any doubts?
No, sir.
Yeah. Thank you all.